Hello everyone, my name is Shujing Zhang. I'm an honor student in the University of Tasmania. I'm going to give a short introduction to my research, uncertainty in sea level fingerprints associated with future Antarctic ice sheet melting in the 21st century. In this research, I have three co-authors. They are Dr. Xibing Zhang, Professor Matt King, and Dr. Stephen Phipps. Firstly, with continuing global warming, our global sea level is rising. And for the people who lived in coastal cities, they experience different regional sea level change. And that deviation in the regional sea level change is contributed by many processes. But in this study, we are going to focus on the processes of ice happens on the ice sheets and shelves. So the regional sea level distribution in response to the mass exchange between the land ice and the ocean is called sea level fingerprints. On the right figure here is an example of sea level fingerprint in response to the Antarctic ice sheet uniform melting, which results in global mean sea level rise by 1 millimeters. So the regional distribution shows that the sea level in the regions near the Antarctic is going to fall, but in the far field, the sea level is going to rise and the number is increasing with the greater distance from the Antarctic. To get that sea level fingerprints, we need to get the mass redistribution of ice on the ice sheet. The scientists have produced many ice sheet simulations, and those studies showed that there is a great difference in the evolution of the Antarctic ice sheet in the 21st century. For example, in the paper from Sarose et al. 2020, there are huge uncertainties shown in the simulated ice thickness change over the Antarctic in the 21st century. And as a consequence, the uncertainties in the ice will be reflected in the large uncertainties in the global mean sea level change. In the right figure here from the same paper, this is the resulting global mean sea level change due to the Antarctic ice sheet melting from their different ice sheet projections. And the uncertainty is pretty large, as some number is up to 200 millimeters at the end of the century. So given that large uncertainties in the global mean sea level change, we have two important scientific questions. What about uncertainties in the local sea level change at coastal cities? And also, for the coastal cities, which part of the ice on the Antarctic ice sheet should the cities most care about? So here is our result. This is a result of high-resolution sea level fingerprints and uncertainties associated with Antarctic ice sheet melting in the 21st century under RCP 8.5. Panel A is the mean of the sea level change, and B is the standard deviations. The number here on the top of the panel A is 308 millimeters for the global mean sea level change predicted. So we divide the global ocean into three regions. In the near field of the Antarctic, there is a strong sea level falling predicted, also with strong uncertainties. However, if we move to the region around 60 south degree latitudes, the sea level here will have almost zero change and also with small uncertainties here. But in the far field, the sea level here is going to rise, and the number will be increasing with a greater distance from Antarctic. and that increasing is also occurred in the uncertainties for that reason. Here's another result, shows the quantified sea level contributions and uncertainties from 27 drainage basins of the Antarctic to some coastal cities under RCP 8.5. So right panel on the top is the map of the drainage basins over the Antarctic, and on the bottom is the map of the cities, coastal cities. On the left figure here are three panels. Panel A is the predicted ice thickness change on the Antarctic for all drainage basins. And panel B is the local sea level at two coastal cities that are Cape Town and Wellington, and they have different sensitivities for the ice thickness change among that drainage basins. And panel C shows the quantified sea level contributions from the drainage basins to that two cities. So we're going to use that result to illustrate that for the coastal cities, when they consider which drainage basin should they most care about, they should consider two important factors, that is ice thickness change and local sea level sensitivities. For example, here, if we focus on three basins here, look at basin 12, the ice thickness in this basin is predicted to have smaller change compared to basin 9. And also, the local sea level sensitivity of the basin 12 is smaller than that sensitivity for basin 17. But the overall sea level contributions from basin 12 is the largest among the other basins. That is because although they have not the largest thickness change and local sea level sensitivity, but the combination of that two factors is the largest in that basin. So it has the largest sea level contributions for that basin. And thanks for listening. If you're interested in this topic, please look at my poster at the conference. Thank you.